Okay, good morning, all of you. This is the part 21 of excretory products and their elimination. Okay, in the 19th part and 20th part, okay, we learned mechanism of concentration of filtrate, and this is the third part about counter current mechanism. Mammals have the ability to produce concentrated urine. Okay, Henley's loop and Vasorector play an important role in the formation of the concentrated urine. Okay, those two play an important role. Okay, right. The flow of filtrate in the two limbs of Henley's loop is in counter current fashion in opposite, and the flow of blood through the two limbs of vasa recta, the flow of blood through the two limbs of vasa recta is an opposite. Okay, that means that is also one counter current. Okay, in counter current pattern, the proximity between. Okay, another important point here, they are very close. Okay, between the proximity, nearness between the Henley's loop and Vasorecta as well as counter current in them help in maintaining increasing osmolarity towards the inner medullary interstitium, that is 300 milliosmoles. 300 milliosmoles in the cortex, 300 milliosmoles in the cortex and 1200 milliosmoles in the medulla. And in the this gradient is mainly caused by, okay, they are very close to each other, and the counter current, there is a counter current pattern, and this gradient is mainly caused in the medulla by two substances. One is NaCl, another one urea. Okay, NaCl is transported by the ascending limb of Henley's loop. NaCl is transported by the ascending limb of Henley's loop, and it is exchanged. It is exchanged. This is the counter current exchanger system. Counter current exchanger system గా పనిచేసేది ఎవరంటే, ద ఇంపార్టెంట్ పాయింట్, కౌంటర్ కరెంట్ మల్టిప్లయర్ గా పనిచేసేది Henley's loop act as a multiplier. Henley's loop act as a multiplier system. In the counter current mechanism, there is a counter current multiplier and a counter current exchanger. The structure that acts as an exchanger is the vasa recta, the structure that helps in increasing osmolarity, that is multiplying the osmolarity in the interstitium. That is okay, Henley's loop. This is the Henley's loop. These are all diagrams indicating seven Henley's loop. Okay, look at this one, the osmolarity in the interstitial fluid in the medulla. Okay, in the medulla there is a fluid called tissue called interstitium. In the interstitium there is a fluid called interstitial fluid. In the medullary interstitial fluid from the cortex towards the medullary papilla. Okay, the osmolarity in the beginning is 300, but if you observe this one, it has become 1200. The main who is increasing this osmolarity, that is a Henley's loop. That's why it is called counter current multiplier system. It is a multiplying. The NaCl is transported by the ascending limb, which is exchanged with descending limb of vasa recta. This is the descending limb of vasa recta. This NaCl is transported into this one. Okay, next point is NaCl, which is returned to the interstitium by the ascending portion of the vasa recta. Okay, observe this one. This is the ascending portion of vasa rectum. This ascending portion of the vasa rectum, again it gives back the NaCl. Okay, they did not show here. Okay, it gives NaCl and it takes, you can see in this textbook. Okay, it is giving NaCl. What is this one? Ascending limb of vasa rectum. It is giving the NaCl back into the interstitium and it takes water. Okay, this segment, it takes water. Okay, that's why look at the osmolarity in the vasa recta. It is 300 here. Okay, as it is moving down here, the osmolarity increasing in the blood. Why it is increasing? Because NaCl solute is coming here, that's why osmolarity has increased here. Why the osmolarity decreasing in this ascending limb of vasa rectum? Because NaCl solute is coming outside, therefore osmolarity decreases. Okay, that is the main reason. In the here there is a decrease in osmolarity and increase in osmolarity here. Here NaCl is coming inside. Here in this segment NaCl is going outside. The NaCl is returned to the interstitium by the ascending portion of the SR recta ద్వారా మళ్ళీ ఇక్కడికి వస్తుంది. Therefore, the osmolarity in the medulla is maintained by this one. It is established by, okay, it is established by ఎవరు ఈ ఆస్మోలారిటీని ఇక్కడ ఎస్టాబ్లిష్ చేస్తారంటే హెన్లీస్ లూప్. దాన్ని మెయింటైన్ చేసేది ఎవరంటే వాసా రెక్టా మెయింటైన్ because the NaCl that is coming from this part, it is taken by this part and again it is returning back to maintain osmolarity. Okay, the osmolarity, the increasing osmolarity is it is established by హెన్లీస్ లూప్. దీన్ని ఎస్టాబ్లిష్ చేస్తుంది, దాన్ని మెయింటైన్ చేసేది ఎవరంటే, ఫర్ ఎగ్జాంపుల్ టు అండర్స్టాండ్ ఈజీలీ, okay, and if you go to movies, for example Chiranjeevi, if you take Chiranjeevi, okay, he good reputation is there in the cinema industry. ఓకే, వాళ్ళ నాన్న ఓకే రామ్ చరణ్ తేజ్ ఇస్ సన్. వాళ్ళ నాన్న తెచ్చిన పేరుని ఓకే ఇతను కంటిన్యూ చేస్తున్నాడు, అంటే అతని నేమ్ స్పాయిల్ చేయకుండా. ఇక్కడ ఎవరు ఈ 1200 ఆస్మోలారిటీని ఎవరు ఎస్టాబ్లిష్ చేశారు? హూ ఎస్టాబ్లిష్ దట్ 1200? ఎవరు ఎస్టాబ్లిష్ చేశారు? లూప్ ఆఫ్ హెన్లీ. దట్ 1200 అంటే దీన్ని కంటిన్యూ చేయాలి. Who is continuing that? Who is playing an important role in continuing that? Okay, vasa recta play an important role. It is again giving back the NaCl. Therefore, here the osmolarity is maintained. Okay, it is very important point. It is established osmolarity, 1200 osmolarity in the medulla is established by Henle's loop. It is maintained by vasa recta. Okay, similarly, small amounts of urea enter the thin segment of ascending limb and which is transported back to the interstitium by the collecting duct. I told you yesterday this one. The above, in the previous part, the above described transport of substances facilitated by special arrangement of Henle's loop and vasa recta. It is possible only because of special arrangement of the. If this is not here, what is not here? If vasa recta is not here and this NaCl is not exchanged with this one, therefore the osmolarity cannot be maintained. Okay, that's why the special arrangement of Henle's loop and vasa recta, okay, called counter current mechanism. This mechanism helps to maintain concentration gradient in the medullary interstitial tissue. Presence of why 1200 is important here? Presence of such interstitial gradient concentration helps in easy passage of water. Here, observe here, lot of water coming. If you come here, water is not coming, much water is not coming. Okay, here osmolarity 300. Here this fluid also has osmolarity. Okay, here it is in the first segment of DCT is isotonic, it is hypotonic. In this segment it becomes isotonic. ఇది టెక్స్ట్ బుక్ లో ఇవ్వలేదు మీకు ఎక్కడ. It is very important. Okay, in the DCT, in the first part of the DCT, it is hypotonic because here, okay, I am comparing with blood osmolarity 300 but it is 200. It is hypotonic to the blood. When it comes here, okay, it becomes 300. Okay, then we call it isotonic to the blood. And that is, as it is moving down, what is coming outside? Solvent is coming. Solvent means water, therefore solute concentration increasing. Okay, here lot of water is coming. Why this lot of water is coming outside? Because of increasing osmolarity. Okay, that's why here concentrated urine is formed. Okay, presence of such interstitial gradient interstitial helps in easy passage of water from the collecting. What do we call this part? Collecting that, and thereby concentrating the filtrate urine. Human kidneys can produce nearly 4 times concentrated urine than the initial filtrate form. Okay, right. Let us see. You can note down these points. Assertion, reason. Okay, come to this last part. Medullary interstitium concentration increases. Interstitium concentration increases from the upper to deeper medulla, 300 to 1200. Reasons: reabsorption of water into the blood. Okay, reabsorption of water into the blood from the absorption of water from the blood. Okay, into the blood from the medulla. Who is doing that? Okay, observe here. Reabsorption of water. If you see this part, water is taken by this part. Water is coming from this segment. What is this one? Descending limb of Henle. So that water is entering into the blood of this ascending limb of vasa recta. Okay, that is one thing. Other, if water comes here, the osmolarity of the interstitial fluid decreases. Now it is 300 to 1200. Okay, if water comes here, if water does not enter into this part, this osmolarity decreases. Okay, as the water is entering into the blood, the osmolarity is reabsorption of water into the blood from the medulla and medulla to blood water by osmosis. Next, another point, adding of NaCl from the blood in ascending limb of vasa recta into medulla. Okay, blood from the blood, NaCl by a process called active transport, it is coming into medulla. I showed you that one earlier. From the blood, vasa recta has blood. This is vasa recta has blood. From the blood, NaCl is coming outside by active transport into the medullary interstitium. Okay, that's why here there is a osmolarity is maintained. That is one reason. And third reason is reabsorption of urea from the renal filtrate in the collecting duct into medulla. Okay, reabsorption of urea from the renal filtrate in collecting duct into medulla. I will show you. Okay, observe here. Reabsorption of urea from the collecting duct in the into the medulla. It is also increasing osmolarity here. Okay, these are the things that are causing increasing osmolarity here. What happens if the medullary interstitium concentration falls? For example, if the interstitium concentration it becomes 300, what would happen? Medulla loses reabsorption capacity. This reabsorption does not take place. If the osmolarity it is not 1200 here, okay, this water does not come here. Therefore, our urine will be dilute. Urine will be dilute. Okay, hypotonic urine, that is called medulla loses reabsorption capacity. Therefore, hypotonic urine is produced. Generally, what type of urine we produce? We produce hypertonic urine. Okay, this is the NaCl. How NaCl is coming from ascending limb of Henle's loop. So NaCl is coming from ascending limb of Henle's loop, and that NaCl is entering into the medulla. It is coming into this space. This is called medullary interstitium locostundi. From there, it is entering into the descending limb of vasa recta. From here, it is entering into the descending limb of vasa recta, and again it is coming from this segment, and again from the ascending limb of vasa recta. Again, it is coming back. It is coming back into this space called medulla. Okay, in this way, NaCl moves, and here earlier I told you urea recycle. How urea is recycling. Okay, that's the end of concentration of the filtrate.